Hello and welcome. This is video number 131 and I am starting another series of lectures on Introduction to Statistics. This is lecture number 1 and in this lecture I am going to focus on basics of statistics, and I dedicate this video to Prem Man, and this is based on Introductory Statistics edition. So this whole presentation is based on Prem Man book, Introductory Statistics. So this is his work, and I dedicate this to Prem Man. So ladies and gentlemen, let me start with the definition of statistics. Statistics is the science of collecting, analyzing, presenting, and interpreting data, as well as of making decisions based on such analysis. There are different types of statistics. The first one is descriptive statistics, and descriptive statistics consists of methods for organizing, displaying, and describing data by using tables, graphs, and summary measures. This is a kind of case study, how women rate their lives. So this is a kind of descriptive statistics, and here you see pie diagram, and in which you see 63% of the women reported that they are struggling, 24% of them reported thriving, and some 13% reported that they are suffering. So this is a kind of descriptive statistics, and this is a pie diagram, and there are three types of answers to this question, and the answers are in percentages. Another type of statistics is inferential statistics. Inferential statistics consist of methods which use sample results to help make decisions or predictions about a population. There is a difference between population and sample. A population consists of all elements, that is, individuals, items, or objects whose characteristics are being studied. The population that is being studied is also called target population. On the other hand, a portion of the population which is selected for study is referred to as a sample. So a sample is a subset of a population. It's from population, and it is a portion of the population which is selected for study. Here is an example. This figure portrays the difference between population and sample. On the left hand side, you see this is population, and it consists of all elements under consideration. So all these red circles or dots are the elements or items or objects which are contained in this population, and on the right hand side you see this is a portion of this whole population. So this is a sample. So a sample is a small portion of the population. So you see population contains a large number of elements, whereas this sample contains only 1, 2, 3, 4, 5, 6, 7 elements. So it's a part of the population. A survey which includes every member of the population is called a census. The technique of collecting information from a portion of the population is called a sample survey. So one is census and one is sample survey. In census, we include each and every member of the population, whereas sometimes we select a sample from the population and then we make a survey, and that survey is called as a sample survey. A sample that represents the characteristics of the population as closely as possible is called a representative sample. And this is very much needed for your research. If you select a sample from the population, it must be representative. If it is not representative of the population, then your results may not be reliable. A sample drawn in such a way that each of the elements of the population has a chance of being selected is called a random sample. If all samples of the same size selected from a population have the same chance of being selected, we call it simple random sampling. Such a sample is called a simple random sample. A sample may be selected with or without replacement. In sampling with replacement, each time we select an element from the population, we put it back in the population before we select the next element. So this means we have sampling with replacement. Sampling without replacement occurs when the selected sample is not replaced in the population. We don't put it back in the population before we select the next element. An element or member of a sample or population is a specific subject or object, for example, a person, a firm, an item, a state, or a country about which the information is collected. Then we have variable. A variable is a characteristic under study that assumes different values for different elements. In contrast to a variable, the value of a constant is fixed. The value of a variable for an element is called an observation or measurement. A dataset is a collection of observations on one or more variables. Here is an example. In this table, this is the total revenue for 2010 of 6 companies. Now here are the 6 companies: Walmart stores, Royal Dutch Shell, ExxonMobil, BP, Sinopec Group, China National Petroleum, and here are the total revenue. These are in millions of dollars. So this particular value is an observation or measurement, and this is in element or a member of these companies, and this is total revenue. This is variable. So you see, total revenue varies from company to company. So this is how observation, element, or a variable can be distinguished from each other. Then there are types of variables. Variables may be quantitative or qualitative. Quantitative variable may be discrete or continuous. Qualitative variables are also called categorical variables. Quantitative variables. A variable that can be measured numerically is called a quantitative variable. The data collected on a quantitative variables are called quantitative data. A variable whose values are countable is called a discrete variable. In other words, a discrete variable can assume only certain values with no intermediate values, say for example age, consumption, income, height, weight, and so on. These are discrete variables, but these are quantitative variables also. Then we have continuous variable, a variable that can assume any numerical value over a certain interval or intervals is called a continuous variable. Now age and weight or speed of a car are types of a continuous variable. A variable that cannot assume a numerical value but can be classified into two or more non-numeric categories is called qualitative or categorical variable. For example, male, female, yes, no, black, white, Muslim, non-Muslim, and so on. The data collected on such variable are called qualitative data. Here are the types of variables. With the help of this figure, you can see here is the variable, here is the quantitative variable, and then within quantitative variable we see discrete, for example, number of houses, cars, accidents, number of deaths, continuous, length, age, height, weight, and time. These are continuous variable. And here you see qualitative or quantitative categorical variables. For example, make of a computer, opinions of people, gender, and so on. Data may be cross-section or time series. It can also be panel data. So here, this is just for the beginners. So we just differentiate between cross-section data and time series data. Uh, Data collected on different elements at same point in time or for the same period of time are called cross-section data. For example, this is an example of cross-section data. This is total revenue in millions of dollars, and these are companies, and this data is for say 2010. So this is cross-section data for the same period of time. Then there is time series data. Data collected on the same element for the same variable at different points in time or for different periods of time are called time series data. For example, data on GNP, data on national income, data on imports, data on export, data on investment, consumption, saving, and so on. And here is an example of money recovered from healthcare fraud judgment. So this data is on the same variable over a period of time, that is 2006, 2007, 2008 till 2010, and these are billions of dollars recovered. So this is a kind of time series data. Data could also be panel data. When we combine the cross section and time series data, we get panel data. These are sources of data. Data may be obtained from internal sources or external sources. We may also call them primary sources or secondary sources. Primary sources are those when we collect data for the first time, and secondary sources are those which are in published books or reports, surveys, and so on. We also obtain data from surveys and experiments. Here are some notations, and in statistics and mathematics we use this notation more often, and that is summation notation. Suppose a sample consists of 5 books and the prices of these books are as follows. Book number 1 costs $175, price of the second book is $80, price of the third book is $165, price of fourth book is $97, and price of the fifth book is $88. So the variable price of a book is X. Let us suppose X stands for a price of a book. So this is a variable. It varies from book to book. So price of the first book is X1, price of the second book is X2 up to X5. So adding these prices of all the 5 books gives X1 plus X2 plus X3 plus X4 plus X5, and that is equal to 175 plus 80 plus 165 plus 97 plus 88, and the sum is equal to 605. So we can write that mathematically summation xi, where I varies from 1 to 5, and that is equal to 605. So this is the summation notation, and summation notation means we add all prices of the 5 books. Here is an example. Annual salaries in thousands of dollars of 4 workers are 75,000, 90,000, 125,000, and 61,000 respectively. Then find number 1 summation x, b summation x whole square, C summation x square. So here is the solution. Summation x is equal to x1 plus x2 plus x3 plus x4, where x1 is 75, x2 is 90, x3 is 125, and x4 is 61, and the sum is equal to 351. So we can write that in $351,000. The second question was summation x whole square. So that is the square of the sum of all x values. So we will square this. So summation x whole square is equal to 351 square, and that is equal to 123,201. So this is summation x is equal to 351. Summation x whole square is equal to 123,201. The C part of the question is the expression summation x square is the sum of the squares of x values. To calculate summation x square, we first square each of the x values and then sum these squared values. For example, we can write summation x square is equal to 75 squares plus 90 square plus 122 square plus 61 square, and the 75 square is equal to 5625, and this square is equal to 8100, and this is equal to 15,625, and this square is equal to 3,721, and if we add up all these, we get 33,071. So there is difference between summation x square and summation x whole square, because summation x square is equal to 33,071, whereas summation x whole square is equal to 123,201. So you must be very careful about calculating these values. There is a big difference between summation x whole square and summation x square. Here is the example. The following table lists 4 pairs of m and f values. M is 12, 15, 20, 30, and f is 5, 9, 10, and 16. So the question is how to compute the following: summation m, sum of m, these values, then sum of f square, and then summation mf and summation m square f. So we can write m1 is equal to 12, m2 is equal to 15, m3 is equal to 20, m4 is equal to 30, f1 is equal to 5, f2 is equal to 9, f3 is equal to 10, excuse me, f4 is equal to 16. So the m values are there. So if we sum these values, we get summation m, and that is equal to the sum of these 4 values is equal to 77, and this is the sum of f, that is equal to 40, and f square is this is f. So we square this, 5 multiplied by 5, then 9 multiplied by 9, then 10 multiplied by 10, then 16 multiplied by 16. So we get these values. 5 into 5 is equal to 25, 9 square is equal to 81, 10 square is equal to 100, and 60 square is equal to 256. So if we sum up these values, then we get summation f square, and that is equal to 465. Then we come to mf. What we do, we multiply m with f. So we have 12 5s are equal to 60, 15 9s are equal to 135, 20 10s are equal to 200, and 30 16s are equal to 480. And if we sum up these, then we get summation mf, and that is equal to 875. Then we come to m square f. Since we need to calculate summation m square f, so first we need to have m square. Here is m. So first we square this. So 12 multiplied by 12, and then f is equal to 5. So 12 into 12 into 5 is equal to 720. Then 15 into 15 into 9 is equal to 2025. Then 20 into 20 into 10 is equal to 4000, and 30 into 30 into 16 is equal to 14,400. And if we add up all these values, then we get summation m square f, and that is equal to 21,145. These are small examples, and this is how we can enter and save data in Excel. Usually we see in the first column we have number of observations, numbers, and then we have A, B, C columns. So we can write year, and then we can write sales, and we can write employee name. So this is how we enter or put data in Excel. Again, this is January, February, March, and these are some numerical values, dollars, and these are some percentages, and this is if, for example, if you want to calculate the square of this, then you write like this: equal sign b1 hat 2. So if you press this, then it will calculate the square of this. Similarly, here also, if you copy, then it will calculate square for these values also. Yes, and here in this you see this is the formula. The square of this is equal to this, and the square of this is equal to this, square of this is equal to this. So if you want to sum up all these, then here you will get the addition of all these maybe in the next. So ladies and gentlemen, this was a brief introduction to various concepts, topics in Introduction to Economics. This video is meant only for the beginners. Thank you for watching. If you like the video, kindly subscribe to the channel and share it with your friends and with your colleagues, so that it can reach to maximum possible number of people. And kindly do not forget to click on bell icon, so that you can get notification about my other videos that I'll upload. Thank you, and have a good afternoon and happy weekend.